This video is about solving for the skewness and kurtosis of a certain distribution. Let's start first with skewness. Skewness is used to mean the absence of symmetry from the mean of the dataset. Skewness is used to indicate the shape of the distribution of a certain data. There are two kinds of skewness, positively skewed and negatively skewed. When we say positively skewed, the curve is extended to the right. So if I will draw a distribution, most of the scores are concentrated on the right. That's why it's all positively skewed. While negatively skewed, the curve is extended to the left. That means most of the scores are on the left side of the distribution. Okay? So there are just two kinds. Again, the positively skewed and the negatively skewed. Positively skewed, most of the scores are concentrated on the right, and negatively skewed, most of the scores are located on the left or found in the left. Now, how do we solve for skewness? We will use the different percentiles in order for us to solve for this one. So skewness is equal to P90 minus 2P50 plus P10 all over P90 minus P10. So if the result is a positive number, then the data is positively skewed. If the result is a negative number, then the distribution is negatively skewed. So again, we have to recall the formula for the percentile. And the formula for the percentile is P of K is equal to the lower boundary plus Kn over 100 minus CFP over f of pk times I, because we need the percentile formula for this one. Next is the kurtosis. Kurtosis is defined as the parameter of relative sharpness of the peak of the curve. We have three kinds of kurtosis. It can be leptokurtic, wherein the peak is sharp with flat tails. So as you can see in the diagram, it's the one with the red. It's the one drawn as red. Mesokurtic is medium peaked, and platykurtic is the flattest peak and highly dispersed. So this means when the distribution is leptokurtic, most of the scores are concentrated in the mean median, near the mean median and the mode. When it's mesokurtic, it's normal. No? They're evenly distributed between the mean, the median, and the mode. And for platykurtic, it's highly dispersed, or the scores are very far from each other. And for the kurtosis formula, we have the quartile deviation over P90 minus P10. So what is the quartile deviation? If you will recall in your previous grade levels on how to solve for quartile deviation is equal to Q3 minus Q1 divided by 2. So again, you need the formula for quartile and the percentile here. So recalling the formula for the quartile, we have lower boundary plus 3n, not 3n, kn plus kn over 4 minus CFP over f of qk times I. So for the percentile, we already reviewed that in the previously. Okay, so let us concretize our learning by doing an example. So let us solve for the skewness and kurtosis of this data. So in order for us to solve for the skewness, I will write here the formula. So skewness is P90 minus 2P50 plus P10 all over P90 minus P10. And for the kurtosis, we will be we'll have the formula QD over P90 minus P10. So we need to find Q3, Q1, P90, P50, and P10. Okay, so let's solve first for quartile 3. So we'll have lower boundary plus 3n over 4 minus CFP over f of Q3 times I. So solving for the locator, 3n over 4, that is 3 times 35 divided by 4, and that would give us 26.25. So if we locate that in our CF less than, we will find that this here in 30. So we cannot use 26 because that's until 26 only. So we'll be using 30. And then our CF less than is 26. Our our frequency is 4. So substituting, we have Q3 is equal to the lower boundary, which is 29.5 plus 26. Oh, sorry, not 26. It's 30 times 30 minus 26 divided by 4 times 5. Hence, when you solve this one, you will have 30 minus 26 divided by 4. So that's 1 times 5. That's 5 plus 29.5. That gives us 34.5. Okay. Then let's solve for Q1. So Q1 is a lower boundary plus n over 4 minus CFP over f of Q1 times I. So solving for the locator, n over 4 is 35 over 4. That would give us 8.75. Locating that in our CF, we have to go with 10 because yung 8 is until 8 only. So we go with 10. And then the CFP is 8. The frequency is 2. So Q1 is equal to, that's 14.5 for the lower boundary, times 8.75 minus 8 divided by 2 times 5. I'll just put that there. There's no space. So we will have 8.75 minus 8 divided by 2 times 5 plus 14.5. That would give us 16.375. Okay, but oh wait, I think I made a mistake here on this part. It should not be 30. I don't know why I wrote 30 here. Let us solve this again. Okay, so let's go back to Q3 because I wrote the wrong number there. So it should be 26.25 minus 26 divided by 4 times 5. So if we solve that again, we have 26.25 minus 26 divided by 4 times 5 plus 29.5, and that will give us 29.8125. Or if you want to just 2 decimal places, it's 29.81 when we round off. Okay, so I think this one is correct already. Okay, now let's go to solving for the quartile deviation because we need that later. So for the quartile deviation, that is Q3 minus Q1 over 2. So we will have 29.81 minus 16.375, or let's just round it off to the nearest 2-digit. So let's just write 38 divided by 2. So we'll have 29.81 minus 16.38. That gives you 13.43 divided by 2. The quartile deviation is 6.72 to the nearest decimal, 2 decimal places. Okay. Next, we need to solve for P90, P10, and P50. Okay, so let us solve for P90 first. So P90 is lower boundary plus 90n over 100 minus CFP over f of P90 times I. So 90n over 100, that would give you 90 times 35 over 100. And the answer to that is 31.5. So we need to look for 31.5. So it's here, the last class interval. Okay, so the CF is, I'll change to yellow. The CFP is 30, the frequency is 5. So solving for P90, so P90 is 34.5, that's the lower boundary, plus 31.5 minus 30 divided by 5 times 5. And if we simplify that, 31.5 minus 30, that's 1.5, divided by 5, that's 0.3, times 5, that's 1.5, plus 34.5. Then P90 is equal to 36. Okay. Okay, let's solve for P10. We don't have space anymore. Okay, let's solve for P10. I'll put it here. So P10 is lower boundary plus 10n over 100 minus CFP over f of P10 times I. So let's have 10n over 100. So that's 10 times 35 over 100. And that would give you 35. 3.5. So 350 divided by 100, that will give you 3.5. And if we locate 3.5, we can see it here in 5. So there's no CFP here, so it's 0, and then the frequency is 5. So let's try that. So P10 is equal to 4.5 plus 3.5 minus 0 divided by 5 times 5. So P10 would be 3.5 minus 0 is 3.5 divided by 5 is 0.7 times 5 is 3.5 plus 4.5 is 8. Okay. So again, we have the value of P10 as 8. So we can now solve for the kurtosis, right? So kurtosis is equal to QD, that is 6.72. Here is our QD. So 6.72 divided by P90 is 36 minus P10 is 8. So if we subtract first 36 minus 8, that is 28. So 6.72 divided by 28, that gives us a kurtosis of 0.24. Okay, so what does this mean? If it's 0.24, is it platykurtic, leptokurtic, or mesokurtic? So as you can see, it's a positive value. It's above 0, it's greater than 0. Then it is the graph or the distribution is leptokurtic. Okay. Now let's solve we actually need P50, right? So I'll just erase some parts here. because we need P50. We need to solve for P50 in order for us to solve for the skewness of the data. Okay, so let's have P50, and P50 is lower boundary plus 50n over 100 minus CFP over f of P50 times I. So solving for the locator, 50n over 100, this is 50 times 35 over 100, and that will give you 17.5. So let us locate 17.5. So we can see it here in 21. So this is our P50 class. So I'll encircle 10, that's a CFP, and 11, that's the frequency. So P50 is equal to 19.5 plus 17.5 minus 10 divided by 11 times 5. So P50 would be equal to 17.5 minus 10, that is 7.5, divided by 11, that gives you us 0.68 times 5. It gives us 3.40 plus 19.5. So we have P50 as 22.90. So since we already have all these values, we can now substitute. So P90 is 36 minus 2 times P50, which is 22.90, plus P10, which is 8, divided by P90 is 36 minus P10 is 8. So simplifying, we will have 36 minus 2 times 22.90 plus 8 divided by 36 minus 8. And it will give us an answer of negative 0.06. And since it's a negative number, then we know that the distribution is negatively skewed. This means that most of the scores are located on the left side of the distribution. I hope that you were able to understand how to solve for the skewness and the kurtosis of a certain data.